Section 1.3 is about isotopes and atomic weights. Let's talk about atom. For an atom, the number of electrons must equal to the number of protons. In other words, the number of electrons does not equal to the number of protons is not an atom. It is an ion. When an atom gains electrons or when an atom loses electrons, it becomes an ion. In other words, the number of protons does not equal to the number of electrons. For example, there are more protons than electrons, or there are less protons than electrons. In either case, it is an ion. For example, here we have an element with 6 protons in the core. That's why it shows a 6 plus in the sphere. It's just another way to show there are 6 protons. The next question can be, what element is it? Unless you memorize this by heart, we need to use periodic table to figure this out. This is the periodic table. From the table, we can see different elements with the atomic number, which means the number of protons inside each element. So here, this is hydrogen. Right, as you can see, the one on the top, the atomic number means hydrogen atom has only 1 proton. 2 for helium, 2 protons in helium atom. 3 for lithium and 4 for beryllium. 5 for boron, 6 for carbon. In our example, that picture has only 6 protons, so it is a carbon atom. So if we go back here, this is a carbon atom. Let's count the number of electrons. 1, 2, 3, 4, 5, and 6. The number of electrons equals to the number of protons, the one in the center. Therefore, this is a carbon atom. Let's take a look at this scenario. For some reason, there is a floating electron in the surrounding area. How about let's grab it and then we just insert it into this atom. There. Now there are 7 electrons. The number of protons remain the same, which is 6 protons. The entire system has 1 extra electron. Therefore, this is not an atom anymore. It is an ion. Since the system has 1 extra electron, the net charge is negative. This ion is called anion. The net charge for this anion is -1. Now let's take a look at another element. This element has 7 protons. If we check with the periodic table, for 7 protons, it is a nitrogen. The nitrogen has 7 protons. Now let's check with the number of electrons. 1, 2, 3, 4, 5, 6, and 7. The number of electrons is same as the number of protons. This is a nitrogen atom. For some reason, let's say now let's try to remove 1 electron from this nitrogen atom. We can either shine some laser beam into this electron, let it to energize and vibrate so it can leave the system eventually, or we can apply some heat. Again, this electron is going to vibrate until it reaches to a point and leave the system. Now 1 electron has left the system and 6 electrons remain in the system. With 6 electrons left, the number of protons is 7, so the number of electrons is not same as the number of protons. It's less. This is an ion. The entire system has more proton. It's more positive, so this ion is called cation. So cation means an ion carries positive charge. Now let's take a look at the other topic, which is called isotope. Isotope means same element but different number of neutrons, or in other words, same animal but different weights. One is heavier and the other one is lighter. such as this. So here we have a carbon, right? C means carbon. The subscript 6 means there are 6 protons. The superscript 12 means the number of protons plus the number of neutrons combined. Since the subscript 6 indicates the proton number, 12 means the total. So we use the 12, subtract the 6 protons. There are 6 neutrons for carbon 12. Let's put this carbon 12 over here. Next, we have a carbon 14. This carbon has 6 protons. However, there are 14 protons and neutrons combined. Therefore, 14 subtract 6 equals to 8 neutrons. Carbon 14 has 8 neutrons. In conclusion, both items are carbon items, since each one has 6 protons. However, they have different weights. Carbon 12 has only 6 neutrons, however, carbon 14 has 8 neutrons. Carbon 14 is heavier. You may wonder, what is the application of this? At least one example is we can use isotope to determine the age of a fossil. For example, for a tree, if the tree is alive, it has plenty of carbon 14. However, if you cut a tree and then bury it under the ground, years after years, the neutrons inside the carbon 14 gradually escape from it. The reason is it's heavier, it's bulky, so it's less stable than carbon 12. The carbon 14 going to lose those extra neutrons and become a more stable state, which is the carbon 12. It takes years for the neutrons to leave those carbon 14. If you know how many carbon 14 for a live tree or an animal before it died, and then we can figure out how many carbon 14 left in the fossil, we can estimate how long does it take for this fossil to form. This is one application of isotope. And this is the end of this session.